Hey guys, welcome back. So we're starting video 3, and that's question number 24. A manufacturer of a smartwatch claimed that those that have a watch on inadvertently pay more attention than those that don't. So that's what they think, and they did a sample, and this was the data they collected. So let's take a look. We would not have the luxury of just selecting. You'd have to actually do this question like a free response. So I'm going to talk about that a little bit. All right, so I have two samples, and so I would say state, plan, do, conclude. We will perform a 2-sample T interval for right, I have 2 samples, T interval, because I don't have sigma, I just have the 2 standard deviations, for mu1 minus mu2. I'm trying to figure out if there is a difference between these two methods. And it is mu, not a proportion, because I'm measuring something. I'm measuring how many steps you took in a day. Okay, so it's saying using a degree of freedom of 19. So how is a formula situated here? Our calculator finds a confidence interval by taking our statistic, which that is, was there a difference? So we noticed there was a difference between these two, right? And a critical value. So using degree of freedom of 19, like they said in the question, even though there were 2 values, they told us to use 19. And I looked in my table B and I got 2.861. So I immediately have eliminated these. And the reason why is that this was the 2.576 was the critical value if I went all the way at the bottom of table B where there's an infinity. So when I scooted over to 99% confidence, that number was right above the infinity. And that one I can't use in a T interval because it's not taking into account the degree of freedom. I needed to go higher up on the table. All right, so now what's the difference between these two? It's just this plus sign, and that is in fact on your formula sheet. So that is a plus sign. All right, but let's pretend this was a free response question because that's what kind of a test you're preparing for, right, guys? So if this was a free response question, let's go to confidence interval, right? And I'm doing a 2-sample T interval, and they've given me the summary statistics. So it's good to practice this question. So X1 was 10, 244, S sub X was 1.50, and N is 20. X bar 2 is 8648, S sub X 2350, and N2 is 20. Now, I got to be careful here because my confidence level is 0.99. Okay, beautiful. And just leave pool no. Okay, so let's see what I get. So I did my state, right? I stated we're going to perform a 2-sample T interval for mu1 minus mu2. I would need to check all my conditions. My do, I would need to create my interval. There is my do. And then I would need to conclude. So I would need to say we are 99% confident that the interval from negative 1.33.9 to 33.26 captures the true mean number of steps taken by day by people that do and do not pay attention to their number of steps. Okay. And you might see a follow-up. Notice the number 0 would be in there. So if you think about the question I just did, maybe you didn't watch that video, you might be thinking we do not have sufficient evidence to say that there is a difference. So it's kind of like walking through door number 2. Because the plausible values of the difference between these two, and now instead of dogs and cats, it's the plausible difference between whether you're paying attention or not paying attention, there is no difference. And so this could have just plausibly been because of chance variation. All right, number 25. A student would like to estimate the proportion of the senior class that plans to attend prom this year. The student goes to the guidance and gets a list of all 274 names in the senior class. Using the list, they took a simple random sample of 50 and found that 76% selected yes. She would like to construct a 95% confidence interval. Are the conditions met? Okay, so in a free response, we would answer by actually showing our work. So number one, is it random? So we would actually quote that simple random sample of 50. So that has been met. So I guess we keep going. I'm going to do the large counts, right? We're asking yes or no. So large counts would say N times P or P hat, right? So if I talked to 50 people and the proportion that said yes was 0.76, then that should tell me how many people said yes by merely just multiplying those numbers. So if I multiply those numbers, I get 38 yeses, and that's greater than or equal to 10. And then 1 minus B hat. So that means I got 20 that said no, which is greater than or equal to 10 as well. So I definitely don't have two conditions. I definitely don't have none of them being met. Okay, so now I'm just kind of deciding large counts is not met. Okay, definitely C doesn't work. So I have to, in order to make a final decision, test out the 10% rule. Okay, so if you're missing this question, you really should write out the definition of the 10% rule. And I actually already wrote it out. So let me just show you my work and I'll talk your way through it. The definition of the 10% rule is the population you want to make an inference about must be at least as large as 10 times the sample size. That's the 10% condition. So when I look at my population, it's only 274 because that's the people I'm trying to make an inference about. So that is a problem here. If I took 50, my sample size times 10, I get 500, and my population is not at least as large as that. I would guess that's going to come up on your test. I see it coming. Okay, let's take a look at question number 26. Lexi's a waitress. She believes she earns more tips when she curls her hair. So she did an experiment where she wrote on slips of paper, ponytail or curls, and she shook them up in a hat, and she randomly selected a piece of paper that morning and styled her hair accordingly. She set out to find, is there a difference in the mean number of orders she gets? Ponytail versus curls. Okay, well, she went ahead and did the whole problem. And I'm not going to do it, but I do think this could be on your test. This is how we make a regular free response a little meatier. So let's say she went ahead and did it, and she got a p-value of 0.0375. So that means she could say, because the p-value of 0.0375 is less than 0.5, we reject the null hypothesis. We do have sufficient evidence to conclude that there is a difference in her orders with whether she has curls or ponytail in hair. Okay, but they didn't ask us to do a full free response question. They're asking, what if then they said, making it meatier, what is the definition? And I did exactly this on one of my tests. So the definition of a p-value means assuming H sub O is in fact true, meaning that they really are the same, or another way to say this is that there is no difference. And that's what we always must assume. Even when we want to try to prove it, we must assume there is no difference. Okay, so how can I keep from missing this question? And what would it look like on my test? Because it's going to be different context. We're often asked how to interpret. So this word interpret means you're not supposed to do H sub O, H sub A, right? They're asking this script. not the fail to reject the null thing. Okay, so we say, when I interpret a p-value, I say assuming h sub o is true. So if I go back here, that's what they said here. Assuming that there is no difference between the average orders with curls or the average order with ponytails. Assuming that there is no difference. That is what h sub o is. There is a p-value, and that's what they said. There is and they took the p-value and plugged it in. So there is a blank probability that we should observe a difference in the sample means as great or greater than just by chance. This is the script you'll have to write out on your piece of paper because it's not going to be multiple choice. So be ready to interpret the P. Okay. Oh, that's the last one I had notes, so I must have written most of my notes here. So let's do one more, and I'll put these last. All right, so Josh wants to convince his mom to stop buying single-ply toilet paper. Who could buy toilet paper right now, right? Josh believed that even though Fluffy, a two-ply toilet paper costs more, it would last longer. To help substantiate, he performed a study. Okay, so let's take a look at what he did and how you would do this question, because you're not going to get multiple choice. So here they gave us the X bar, right, and the standard deviation. So they're asking you to perform a test statistic, right? So we will perform a one sample t-test for mu. He only did one sample of 18. So N was 18. And the calculator would come up with these values. So let's get the calculator to come up with those values right now. Okay. So I'm going to scroll down, go to statistics, go to stat test. All right, and he only did a one sample t-test, and so that's here. We were not given the standard deviation of the population. Okay, so mu naught, we're supposed to assume that it is 26, right? So that we could then set up an H sub A that mu is something fewer than 26, okay? We're trying to find, is there convincing evidence to say that it's fewer than 26? Okay, so H sub O is 26, and X bar, we got 24.444. S sub X, we were given 2.45. N was 18, and the sneaky suspicion is it's something less than. All right, so see, there's where we got the p-value and the t. In fact, it's slightly off because I've calculated it. Likely he calculated or she calculated that by hand. So let's assume, well, what's exactly happening here? It's that the calculator ran a sampling distribution. The average was 26, and this would have been the likelihood of a value at least or greater of that. So 2.69 standard deviations to the left is actually pretty darn far to the left, and there's very little area under that curve. So if you were doing a free response, we would say, since the p-value is less than 0.05, we would reject the null hypothesis. We do have sufficient evidence to support the mean number of squares of Fluffy needed to absorb 1/4 cup water is fewer than 26. Check out the next video for 28, 29, and 30.